Cool. Let's get started, everybody. So what I have done today is I have tried to find, well, not tried to find, I have found some sort of slightly more difficult questions for us to do. Maybe the first couple of questions are not so difficult, but in each of these, there are going to be some challenging questions that we are going to have to answer. Now, why is that there? Okay. I think probably the best thing for us to do is delete that, although we're going to have to go up and down here. But anyway, never mind. Okay. So I can't remember which final paper this comes out of, but you'll see this on the department's website. And the reason that we are doing this particular question is because of question 6.3. We're not too worried about 6. Well, we are obviously worried about 6.1 and 6.2. We want to get those correct. But the real reason that I'm doing this with you today is because I want us to do question 6.3 together, which we will get to in due course. All right. So let's just read the information. It tells us in the diagram, the graphs of f of x, which is sine x minus 1, and g of x, which is cos 2x, are drawn in the interval from minus 90 to 360. They intersect at A, which has the coordinates. Oh, they didn't tell us the coordinates, sorry, and B. Why do I not see? Oh, there's B over there. And B has the coordinates 360 and -1, which is a point on F. So I don't know about you guys, but I always highlight the graphs for myself. And then I go and I highlight them over there just to draw. But you don't obviously have to do this, but I think it helps, especially when we are working online. Okay, and obviously I'm not doing such a brilliant job here. I just don't want to waste time highlighting the graph. There we go. Okay, now let's go and have a look at the questions. The first thing that they want us to do in question 6.1 is they want us to write down the range of f. So what is the range of f? Can anybody tell me? Don't be shy, guys. You can pop it in the chat if you don't feel like speaking. That's it, Linda. What about everybody else? What's the range of f? You guys are so quiet today. So it's your sine x graph. It's been shifted down 1 unit. That's cool, Trish, 100%. Okay. So Lisedi, that's also okay. The only thing that you just need to be careful of, guys, is that when it comes to a sine graph and a cos graph, remember there are no asymptotes. So we're going to include our minimum and maximum values. All right, so you have a choice. Here you can say y is an element from our smaller value first, so square brackets, -2 up to 0. Or the other way in which you can set this out is you can say y is greater than or equal to -2, but smaller than or equal to 0. Okay. Hopefully that makes sense to everybody. And there would be 2 marks, answer only. You can't, either you write it like this or you write it like that. There's no other way of writing that particular answer. Okay. Question 6.2 asks us to write down the values of x in the interval from -90 to 360 for which f is at a minimum. So where is that going to be? Where is f at a minimum? Oh, sorry, not a minimum. What am I talking about? Sorry, I'm very tired today. You'll just have to excuse me. For which f is decreasing, not a minimum. I beg your pardon. So for which values of x is f decreasing? What does the word decreasing mean, Matrix? Decreasing means what? Exactly, Letu. Well done. It's got a negative gradient. Oh, I don't know why these don't keep coming up. Yes, Linda, that's correct. Good. Well done. So where the gradient is negative, all right, so that is going to be between, yes, Kamogelo, quite right. Okay, and it doesn't matter how you write that. It's going to be between 90 and 270. Okay, so when x is greater than 90, but smaller than 270. Okay, now, Yolanda, can you please reach out to Mbalenhle just with regards to question 6.1. They're just struggling
Okay.
to understand the range. Mbalenhle. Thank
Okay,
you.
perfect.
Cool. All right. And now onto this monster question 6.3. The reason that we're actually doing all of this, they tell us that P and Q are points on graphs G and F respectively, such that PQ is parallel to the y-axis. If PQ lies between A and B, sure, Zoom user, I'll do that now. Determine the values of x for which PQ will be a maximum. Okay, so there you go, Zoom user. That's it in interval notation. So P and Q are not drawn. P and Q could be over here, or it could be there, or it could be here or here. It's anywhere in between these two graphs because they said it lies between A and B. So it can be anywhere. Correct. So it's so not a y equals, Linda. It's going to be an x equals, exactly. Okay, it's a vertical line. All right. So they want to know the maximum length, or sorry, the value of x at which the maximum length of the line occurs. So you can see here what they are doing, and I hope the rest of you realize this as well, is that they are tying this together with a question, or the sort of questioning that we would expect to see in paper 1. So I don't know if you remember this from grade 11 and grade 12, where we are asked to find the maximum length of a vertical line between two functions. You would, Linda, quite right. So, Linda, you go ahead with that. All right. What you are obviously going to need are the equations. They're over there. Mary Lynn, you've got a hand up. Do you want to ask something, Mary Lynn?
Hi, Miss.
Hi, Mary Lynn.
Miss, I wanted to ask, this is not about 6.3, it's more like 6.2. Like when they
Okay.
when they're asking you to find intervals, are the intervals always on the graph, or do you sometimes have to calculate them?
Well, with a question like this, because it's only out of 2 marks, you wouldn't have to calculate it. So you would just be able to have a look at the graph and see where this condition was taking place. I mean, obviously, you know, the lines here are a little bit faint on your exam paper. It's going to be a little bit more obvious to you than what it would be here. But yeah, if it was something that you had to calculate, it would probably have been worth more marks.
Okay, Miss.
Okay, no problem. Okay, so now the question is, if you want to find the length of a vertical line between two functions, what do you do? So think paper 1, guys. How do you find the length of a vertical line between two functions? What do we say? Can anybody tell me? Lesedi, go for it.
Hi, ma'am.
Hi, Lesedi.
Ma'am, we take the function at the top and we minus the function at the bottom.
Beautiful. Thank you, Lesedi. Perfect. 100%. Okay, and I see some people are saying that in the chat as well. Blue minus yellow, y top minus y at bottom from Lichlu. Good. Would you minus G from F? So it's the other way around, Linda. You are going to say, oh no, you would subtract F from G. Okay, so PQ is the y at P minus the y at Q. So it's going to be G minus F. Okay, so in other words, G of X minus F of X. So the blue graph is cos 2X. And we are going to minus from that sine X minus 1. All right. So you're now going to end up with cos 2x minus sine x plus 1. What do you think we should do with the cos 2x? There's your formulae down here. What do you think we should do with the cos 2x? Write it in terms of sine x. I agree. Good. So because we've got a sine x term in the middle, we're going to write it in terms of sine x. So we're going to replace cos 2x with 1 minus 2 sine squared x minus sine x plus 1. And of course, now we're going to get it into sine squared x minus sine x plus 2. Lovely. All right. So now we've probably got 2 marks out of 6. All right. So what are we going to do to get the other 4 marks? What do you think we need to do now? Remember, we want to maximize the length of PQ. Any ideas? Okay. Do we know how to work with the derivative in trigonometry? Is that part of our syllabus? I mean, it is possible to do that, but do we work with derivatives in trig? No, we don't. Okay. So let's think about something that's inside our syllabus. Aha, Letu, there you go. All right, so Letu, you've got it. If you want to keep going, Letu, and try and get an answer here, you're very welcome. Let's just see what everybody else is. So if we can't use a derivative, how else do we know how to find the maximum length of a line? Bearing in mind that we've got minus 2 sine squared x minus sine x plus 2. What do you think? No, we're not going to factorize. Remember, we want to try and find the maximum length of the line. Okay, so what's difficult for us to see here, all right, is that this expression that we have here for PQ, it is quadratic. It's quadratic, isn't it? So remember, when we're dealing with a quadratic, aha, Trish, good, well done. There we go, Boicho, lovely. The rest of you are starting to catch on now. Okay, so we've got to use the formula that we know for the turning point of a quadratic. Okay, so except the difference here, guys, is that we're working in terms of sine x. So sine x is going to be equal to negative b over 2a. Okay, our axis of symmetry. There we go. All right, that's the only other way that we can actually do this because we can't work with the derivative. Okay, because that's not part of our syllabus. Is everybody happy with that? So now we're going to sub in. I'm just going to get rid of this. There's a little mistake on that, which is not great. And when we sub in, we've got negative b, so that's negative 1 over 2 times negative 2. So that is going to give us negative 1 over 4. Yeah, I don't recall that being one of the answers, Linda. That's not what I got. Okay, I'm going to work through it now, and then maybe you'll be able to find where your mistake was. Yes, but now, Linda, when you calculate, that's it, Kamchelo. Good. Okay, so remember, you don't use the negative to work out your reference angle or your key angle. You use the negative to work in the correct quadrant. Okay, so here, your PAA, or reference angle or key angle, is going to be, I think it's 14,78. Let me just turn a light on here. Do you know that this is actually the first Thursday that I think we haven't had load shedding this entire year? I'm so happy. So shift, there we go. It was 14, highball. What am I doing?
I love the highball. Highball, what am I doing?
Yeah, I was writing nonsense on my calculator. Okay, 14,48. Are the rest of us getting that as well? There we go, Linda. Yes, I think so. Okay, so our reference is 14,48. And of course, if our ratio is negative, then it means that we have to be working either in quadrant 4 or quadrant 3. Okay, so in other words, here's 180, there's 270, there's 360. So the maximum either has to be here in quadrant 3 or it has to be here in quadrant 4. Okay, so we're nearly there at our answer. For quadrant 3, we would say that x is equal to 180 plus 14,48, or it would be 360 minus 14,48 for quadrant 4. Okay, so either 194,48 or 345,52. Okay, which some of you had already sent through to me. Okay, good, Kamachelo. Yes, let's, you're quite nice. Yeah, there we go. All right, lovely. So are we happy with that? Are there any questions you want to ask me? Does that make sense to all of us? Yes, Voloshin, go for it.
Madam, could you just do a brief review of what you did in this question?
Okay, so we were applying. Yeah, I'm going to tell you where the marks would be allocated. All right, so what we were doing is we were applying a little bit of paper 1 knowledge to paper 2. They wanted us to find the value of x for which a vertical line PQ would be at its maximum length. So we said that PQ, if it's parallel to the y-axis, it's going to be the difference in the y at the top and the y at the bottom. So g of x is cos 2x, the y at the bottom was sine x minus 1. So we subtracted those, and then we wrote cos 2x in terms of sine x. So this gave us a quadratic for the length of PQ, minus 2 sine squared x minus sine x plus 2. Because we want a maximum, we don't know how to derive with respect to trigonometric functions. It's obviously possible, but we don't do that as part of our syllabus. So the only way that we could find the value of x at which this maximum length occurs is to use the equation for our axis of symmetry. So minus b over 2a. So when we subbed into minus b over 2a, we got sine x is equal to minus 1 over 4. Because it's negative, when we found our PIA, it means we're either working in quadrant 3 or quadrant 4. Okay, so either where x is equal to 194.48 or 345.52, the length of PQ would be at a maximum. Okay, all right, so there you go. You can take a screenshot. Let's just put the marks on here. So there's definitely got to be a mark for arriving at this point over here. And I would think that there has to be a mark for subbing that in and getting PQ to start off with. Usually, actually, I'm thinking about this now. There could also be a mark over here for selecting the correct. There's always a mark on using an identity. I would imagine there has to be a mark on sine x is equal to this. There obviously have to be marks on our answers. 1, 2, 3, 4, 5, 6. So I would say there. Letu, okay. Okay. Let's go and have a look. Pleasure. Let's go and have a look at another question. I'm just going to make this a little bit smaller. Hopefully everybody can see what's going on here. Okay. And again, the reason that we are doing this particular question is because of question 7.3. All right, so I'm trying to do some problem solving and sort of more difficult questions with you guys this evening. Okay, don't know if you've seen this one before. It also comes out of, yeah, a past paper, end of year past paper. I think this is the 2019 paper, but I could be corrected on that. Okay, so some 3D trig. So in the diagram below, we have a solar panel A, B, C, D, which is fixed to a flat piece of concrete slab, which is EF, C, D. So that's in the horizontal plane. A, B, C, D, and EFCD are identical rhombuses. K is a point on DC such that DK equals KC and AK is perpendicular to DC. AF and KF are drawn and ADC equals CDE equals 60 and AD is X units. So there's a lot going on in this diagram. Okay, let's go and have a look at the questions. The first thing that they want us to do is determine AK in terms of X. Is that okay if I make it a little bit smaller? Can everybody see all right?
Yes, we can see the questions.
Is that
and
okay?
so it's
Yeah,
visible.
it's just unfortunate because now the information in the diagram, the information is not visible. But I mean, pretty much all of this is on the diagram. I suppose what we just need to remember is that ABCD and EFCD are identical rhombuses. Okay, so that is obviously important for us. Okay. Determine AK in terms of X. So remember our brief rules when it comes to our 3D trig. If we are working in a right angled triangle, we use our basic trig ratios. So sine theta is opposite over hypotenuse, cos theta adjacent over hypotenuse, tan theta is opposite over adjacent. If we are working in triangles that are not right angled, that's when we use the sine rule or the cosine rule. Okay. So if we are working with AK and we want it in terms of X, we have to be working in triangle AKD, which is clearly a right angle triangle. So what should we write in this case? Okay, Mbalendle sent me an answer. What about the rest of you? How would we get AK in terms of X? What would you guys write? Okay, you don't have to use Pythagoras and Mbalendle. You're going to use trig. There we go, Letu. Thank you, Linda. All right, so AK is opposite 60. AD is the hypotenuse, that's X. So opposite over hypotenuse, we are going to use the sine of the angle. So that means that the sine of 60 is going to be equal to opposite, which is AK over X is the hypotenuse. And of course, we want AK in terms of X. So that means that we will write AK as X times the sine of 60, and we all know that the sine of 60 is equal to root 3 over 2. Does that make sense to everybody? Yeah, we've got to use special angles. Okay, does that make sense to everyone? Let's just see what you guys are saying here. There we go. Yes. Good, Nhlafatso. Good, Zwanaka. Okay, so Zoom user, remember you're working from the angle that you know. Okay, so you know this angle over here. So it's opposite because they told us they wanted AK. And then X we know is the hypotenuse because it's opposite the right angle. So if it's opposite and hypotenuse, it's got to be the sine of the angle. Okay. All right. And somebody's already sent the answer for the next thing. Let's have a look. Letu, oh, you are on fire, Letu, as always. Okay, write down the size of KCF. So KCF is this angle over here. Okay, so remember they told us up at the top that ABCD and EFCD are identical rhombuses. Okay, they're rhombuses. Good, Kamchelo. So how big is KCF, everybody? Kamchelo's got it. Letu's got it. What are the rest of you saying? Not in this case, Letu, you don't, because it just said write down the size. Okay, so it's just out of 1 mark. Okay. So in this case, we wouldn't provide the reason. Okay. All right. See, why can it not be 60? It can't be 60. Yes, Marilyn, that's a big part of it. Yes, Shasana, that's quite right. Katleho, it can't be 30. If you look at KCF, it looks like it's an obtuse angle. Good, Trish. Okay. So remember, if this is a rhombus, this side over here and that side over there have to be parallel to one another, don't they? And of course, this side over here and this side over here have to be parallel to one another. Okay, so that means, there we go, Katleho, that's better. Okay, it's going to be 120 degrees because KCF and angle CDE are going to be co-interior angles between parallel lines. Okay, nice. Well done, everyone. Okay, so a mark for subbing in, a mark for our answer, a mark on our answer. And now, the real reason why we are doing this question is because of 7.3. So now let's see what they want from us. It is further given that AKF, let's just find AKF, AKF. So AKF is this angle over here. Oh, no, hang on. It's that angle over there. That's AKF. The angle between the solar panel and the concrete slab is Y. Determine the area of triangle AKF in terms of X and Y. All right, so they've told us that angle AKF, the angle between the solar panel and the concrete slab is Y. They want us to determine the area of AKF in terms of X and Y. Okay, so what do you guys think we should do in this case? Where do we start? Okay, so Katlech was saying we're going to use the sine rule. Voloshin says we need to find KF. Ma'am, don't we use the cosine rule? Almost, Linda. I think there's you've made a little mistake somewhere, Linda. You're just gonna have to go back and have a look at that. Obviously, I can't say the answer just yet because everybody else is still thinking this one through. Okay, so if you have a look at this, guys, this is out of 7 marks. So there's quite a lot of work that needs to go into us being able to formulate an answer to this particular question, okay? Because it's, okay, let's just see what you're saying, Letu. So Letu says that dk equals kc. Let's just see what you're saying here. dk equals kc. So you can find dk and then use kc to find kf. All right, that gives us a nice starting point. Okay, Trish, you can try that. Good. DC. Let's just see that. It does. It does indeed. Okay, Trish, you can try that. Okay. As far as everybody else is concerned, okay, if these things are not sort of immediately apparent to you, always try and remember what they've already got you to calculate is going to be important in terms of your final answer, right? So you are quite right in that you are going to have to use the area rule. And hopefully we all know that when we use the area rule, it has to be a side angle side sort of situation, right? So triangle AKF is that triangle over there. We have already got angle y, which is the included angle. We know what AK is equal to. We know that that is root 3 over 2x. So Voloshin, when you said that we need to work out what KF is equal to, you are correct. That is something that we are going to have to take into consideration and calculate. However, we can't work in triangle AKF to begin with. That's where we're going to finish working in. So now we have to say to ourselves, okay, well, we need the length of KF. What else is KF part of? Is it part of another triangle that we know something about that we can start working in? So if we have a look at the diagram, the other piece of information that they gave us is that this angle over here is 120. Remember that EFCD is a rhombus. So if it is a rhombus, it means that all four sides are equal in length. Yes, triangle KCF is very important in this case. All right, so if it is a rhombus, all four sides are equal in length. Hint, hint, hint. Okay, so that means that it is possible for us to determine the length of CF as well, because we know that CF equals EF equals DE equals DC. So what do you think we should do with that information? Okay. So CF equals. Okay, so we're going to use the right. Okay, so Kamogelo, don't worry, we're going to do it step by step. Okay. DC is the same as CF. DC is the same. Okay. So do we know what DC is equal to? Do we know what DC is equal to? Or can we work out what DK is equal to? Yes, Katlego, go for it.
Ma'am, I'm assuming that we're going to use the cos rule because we have 3 angles and 1 unknown sign.
Are you talking?
Length.
Okay, in which triangle?
KCF, ma'am. In order for us to find KF, we use the
You're
cos
right.
rule, ma'am.
We would have to use the cos rule. Okay, but before we do that, we're going to have to do something else. All right, and Letu's just sent me the answer right now. Okay, so we're going to start off in triangle AKD. We need the length of DK. All right, so what we can say is that the cos of 60 is equal to adjacent, which is DK over X. So now if we want to make DK the subject of the formula, DK is going to be equal to X times the cos of 60. And we all know that the cos of 60 is equal to a half X. Is everybody happy with that? Then we know that DK equals KC because this is given to us. So therefore, DC is going to be half X plus half X, which is X. Are we all happy with that? Okay, all right. Now that we have got the length of DC, now we can do what, who was it that was talking to me? I can't remember. Someone was talking to me. Okay, now we're going to go into triangle KCF, and you were saying that we need to use the cos rule. Okay, you are quite right. But before we do that, we are going to say that DC equals CF equals X. Okay, because we have been given that EFCD is a rhombus, and we know that in a rhombus all four sides are equal. Okay, so given EFCD is a rhombus. So now, not that we would need to write this, but in triangle KCF, just so that you guys understand where we are working. All right, we know that KC is X, sorry, half X, and we know that this side is X. So now we can do the cos rule to get KF. Okay, it's a side angle side situation. Okay, so we can say that KF squared is equal to half X squared plus X squared minus 2 times half X cos 120. So I'm doing the cos rule in triangle KCF. Is everybody happy with that?
Yes, yes, ma'am.
Is that making sense? I'm trying to do this quite slowly. Oh, okay. Yolanda, please just reach out to Kamagelo.
Okay.
All right. Kamagelo, I will just do a summary when I'm finished, but Yolanda will give you some assistance. Okay. So now we've got 1/4 X squared plus X squared minus X squared, and then times the cos of 120. So this is going to give us 5/4 X squared minus X squared, and then the cos of 120, I can write that as negative cos 60 if I reduce it. So this is going to give us 5/4 X squared plus the cos of 60 is a half. So this is going to be plus a half X squared. So now when I add those two together, I'm going to times that by 2 to get 4, times that by 2. So this is giving me 7/4 X squared. Is everybody happy with that? Don't think I have made a mistake. Sorry, I'm just checking my calculating here, my working out. I don't think I've made a mistake. I'm just double checking myself, but I don't see that I have got anything wrong here. Okay, so Mary Lynn, I know you asked a question. Hang on a second. What happened to the minus x squared? Okay, so Mary Lynn, the cos of 120, that's second quadrant, right? So it's going to reduce to negative cos 60. So I'm multiplying the two negatives together. That's why I've got a plus. Yes, I reduced. Why did I reduce the 120? Because I want to work with special angles. Okay, so you always have to reduce angles that are not acute. No. I'm not finished yet, Linda. I'm not finished yet. That's just the square for KF. Okay. Why did the second x squared become negative? Which second x squared? You mean, Jamie, do you mean this one over here? Because it's part of the formula because of the minus over here. So you've got your negative. Sorry, that's a negative. I'm now making it look like it's an equal sign when it's not. Okay, so it's negative x squared because of minus 2 times half x times x. Below that. Okay, because a negative, so why did this become negative, you're saying? Because what I did here, Jamie, is I added these two together. Those are like terms, and that gave me this. So that negative there is this negative over here. All right, so Yulandi, you are multiplying a so remember you've got three different terms here. You've got a quarter x squared plus x squared minus x squared multiplied by the cos of 120. So there's the first term, there's the second term, there's the third term. Okay, so these two are like terms. So they can be added together. That's where I get 5 over 4x squared from. Now I'm bringing down the minus x squared multiplied by the cos of 120. Can you guys see it now? All right. And then if I've got 5 over 4x squared, negative x squared, now I'm multiplying this by negative cos 60. So remember my order of operations, I've got to multiply before I add or subtract. So that's why it becomes 5 over 4x squared plus the cos of 60 is a half. So that's why I'm bringing the half to the front and I'm putting the x squared at the back like that. Okay, so that means, I hope this makes a little bit more. Rebetswe, I guess we could, but I think if we use basic trig ratios, it's just going to be faster. Okay, but I mean, theoretically, you could use trig there. You could use Pythagoras there as well. Okay, so what this means for us, guys, we're nearly there, is that KF is equal to the square root of 7 over 2x. Okay, because remember, this is KF squared. So KF squared is 7 over 4x squared. So KF will be equal to root 7 over 2x. Are we happy? We're nearly there now. All right, and now we can do, let's just move that out the way. Now we can do the area of triangle AKF. So the area of triangle AKF is going to be equal to a side angle side. So it's half. AK is root 3 over 2x. So this is root 3 over 2x. The other side is what we've just calculated. That's KF. So that is root 7 over 2x sine y. Okay, and then remember all of this was just separate. I was just explaining my working out there. Yes, Tsechofatso, this is from 2019. Okay, so it's the 2019 paper 2 NSC exam. It's a cool question, isn't it? It's an absolute beast of a question. All right, so now when we multiply fractions, remember we're multiplying numerators together and denominators together. So we've got 1 times root 3 times root 7. So that would give us root 21. 2 times 2 times 2 is 8. X times x is x squared sine y. Okay, and they wanted the area of triangle AKF in terms of x and y. Okay. So, I mean, maybe you'll see on the memo, they would have kind of switched things around a little bit. I don't know. They probably would have gone something like x squared root 21 sine y all over 8 or something. But I mean, we're going to get full marks over here. We don't have to simplify it any further. Okay, so now, Linda, I know you got a slightly different answer. Did you see where you had made a mistake? I don't think I've made a mistake. Sure, Mbalendle. Is that up enough? Pleasure, Linda. Okay, cool. How's everybody else feeling about this question? How do the rest of you feel? Are you okay? Does this make sense? Oh, cool, Keithlin. I'm glad. Oh, Shoshana, you happy? Lovely. Yeah, it was. Oh, good. Yeah, it is a bit scary. I mean, as soon as we see something that's out of 7, it immediately feels very intimidating. So it was a case of working first in triangle AKD to get DK. Once we've got DK, we've got the length of DC. And if we've got the length of DC, we've got the length of CF. Then in order to get side KF, we had to work in triangle KCF and do the cosine rule. Okay, and then eventually, once we've got KF, we can do the area rule working in triangle AKF. So that's why it was out of 7. We had 3 different triangles that we had to work in step by step in order to get our answer. Let's just go through where the marks would be allocated for something like this very quickly. All right, so obviously a mark on our answer. There has to be a mark on getting KF as well. I would say there has to be a mark for subbing in here into KF squared. How many marks is that so far? That's 3. I would also say that getting DK and DC are instrumental in answering this question. So 1, 2, 3, 4, 5. So another 2 marks. Probably a mark for subbing into the area rule. And possibly a mark here on getting that 7/4 x squared as well. Okay. Yes, Voloshin, go for it.
Ma'am, I wanted to ask you, when they say that trigonometric ratio is undefined, what do they mean by that?
When a trig ratio is undefined.
Yes.
Okay. Okay.
Which
So when they're talking about, so you mean solving for values of x for which an identity is undefined?
yes, ma'am.
Okay, all right. So that's going to be when division, so when something is undefined for us, they're talking about when division by 0 takes place. So in other words, if you had something like this, let's say you've got tan theta. So tan theta is undefined because you know that tan theta is sine theta over cos theta. That would be undefined when cos theta was equal to 0. So when division by 0 takes place. That's what they mean. Okay, so trig ratio will be undefined if the denominator is equal to 0. And of course, if your identity contains tan theta, it's going to be undefined at the asymptotes. So you would always have to include where theta was equal to 90 plus k times 180. So you would always have to include that for tan theta. Okay, so in this case over here, it's going to be where cos theta is equal to 0. Where is cos theta equal to 0? So here, this is going to be when theta is equal to, and again, you'd end up getting the same answer as that. It's going to be, so this would be seen as being positive. So it would be quadrant number 1. So 90 plus k times 360. Or the other place is going to be the second quadrant, the fourth quadrant, sorry. So it would be 360 minus 90. So that would be 270 plus k times 360. So you can see how it ties back into that. Okay, but that's what they are essentially referring to. Okay, Voloshin. No, Lutando, probably. But it really depends on what the question is asking you, because, you know, there's another question which comes out of one of the past papers that we'll never see anything out of more than 7 marks. And it was a Euclidean geometry question. And it was also a case of working from one thing to the next, to the next, to the next, to the next. So you could certainly expect, you know, at least 3 steps in a question like that in order to get to your answer. Okay. All right,